Hey developers, S2 here, and we are back for day 3 of the Leet Code 75, the study plan for people preparing for technical interviews. And we are doing some linked list problems. One, merge two sorted lists, which I've actually done several years ago, but maybe I'm better at coding and explaining things, so we'll do it again. And the reverse a linked list, this is actually kind of fun problem. I've had similar ones in different interviews before, so we'll go ahead and do this problem and talk about it as well. So first one, merge two sorted list here. Obviously you have list 1, 2, 4, 1, 3, 4. You merge them, you're gonna have 1, 1, 2, 3, 4, 4. So if the values are the same, they'll get inserted next to each other. And given that these are actual lists defined as nodes, this is just going to involve moving the pointers of the nodes to not look at the next one, but instead look at the one that it should be pointed to for the sorted order. So we're going to be breaking apart nodes, mixing them, matching them, and pointing them back to each other, and we're going to have one big long list at the end of it. Obviously, L1 could be none, L2 could be none, in which case, you have an empty list that looks like this. So if L1 is none, it doesn't matter what is in L2, if it's empty or not, we're going to return that. If not L1, return L2. And if not L2, return L1. That'll cover our edge conditions. And then if we fall through these, then we can assume that there is some value for L1 and L2, in which case we want to, find out which one's bigger, find out which one's smaller, and point them at each other. And to do this, we're going to need some kind of while list and some kind of head node. How do we want to do that? I guess we look at, we'll just go head. Well, we have a current node. Current node equals, maybe we will make a head node. Maybe we won't use it, but for now, we'll just assign it. So head equals current equals none. And then we have a L1 head and an L2 head. Obviously, those are given to us. So, we still need some kind of pointer. So while L1 or L2, I guess like if one of these has a next or the other one has a next, we just keep iterating, right? Then I think we just need some logic checks to go ahead and insert them as the head. So if L1.val is less than L2.val, obviously L1 might not be well, we need to find out how to initialize this node too. I guess if L1.val is less than L2.val, head equals L1, L1 equals L1.next, else head equals cur equals L2, L2 equals L2.next. So that should initialize our nodes, or it should initialize the list that we're going to be looking at. And I think that's fine. then I guess we want the condition where if there's not an L1.next, I guess that means that we're done. How do we know we're done? It has been a while since I have dealt with such a problem. I mean, I guess we can just break. So if not L1 next, that means there's only L2 left. I think we can just do cur.next equals L2 and then break. And then same for if not L2 next. And then break. So that means there's no values left in L1 to look at, and there's no values left in L2 to look at. So just go ahead and join the list. They're completed. Finish the loop. We're good. And then I guess we want to return the head node, right? Yep. We want to return the head, and that is why we made the head. All right, now we just need to look at the next two values. Is there a case where this could be an empty node? I think there is a case where it could be an empty node. Because of this assignment. I mean, technically it's what we want to do, but I guess there won't be an L2 next because it'll be none. But there could be an L1. I'm sure we'll run into that edge case. For now, let's just solve the rest of the logic. We'll think about that a little bit more. So what I'm trying to think about is if we have, let's say L1 equals this. And let's just make these comments. And then L2 equals this. So there will be an L2 next, but there won't be an L1 next. I guess there could even be, well, that just falls through and then that's fine. So cur would equal this. And then L1 would equal none. So if not L1 or not L1 next, I think that's probably the right logic we want to use. And then the other case, if this is flipped. So if not L2 or not L2.next. Now we know we have values we can look at. So if L1.val, I guess that's fine. That's all fine. Yep. If L1.val is less than L2.val, cur.next equals L1. So we want to put in the small one. Else cur.next equals L2. And then I guess we want to move the head pointers. So L1 equals L1.next, L2 equals L2.next. So we're just moving the pointers along. We're moving one into our current node, and then we'll have 3 and 4 be left over. And I think this should be it. So we're dealing with the cases where the nodes are empty. Actually, do I care about this. I think it's okay. 1 2 4 1 3 4 1 1 2 3 4 4 output 1 3 4. It didn't join the L1 node at all. Okay. It did go in our loop, though. Did it? Did it go in our loop? I think it did. All right, let's take a minute to debug this. All right, so we've been looking at this. We got a lot of random weird conditional stuff. And I think we can just simplify a lot of this code by creating a head node. And we'll just call this like a pre-head node equals list node, and we'll just give it a value -1. Since we have this definition here, we can use this to make this. And then we'll do our current node equals prehead, and then we'll set this up. And then we can just do while L1 and L2. I guess we run into a similar situation where L1 could be null. And actually, I guess that's okay, because there will always be that condition we talked about that we're trying to settle here. If there's not anything in L1, just set that as the pointer. We can actually move that outside of the loop. So we're only checking existence that there is L1 and L2 values, which is similar to what we were doing with the ORs, but slightly different. But again, this will clean up the logic. And I think this will mostly be the same. So current.next equals L1, L1 equals L1.next. Yeah. So I think that's fine. Then we need to initialize the rest of our condition where there's not an L1 or there's not an L2. So I think we can use a ternary expression. Cur equals L1 if L1, else L2. I think. And then since we used a prehead instead of initializing the head node, we'll just return prehead.next as our head node, because the prehead is just a placeholder. So let's see how this works, which is obviously much cleaner than before. Cur is not defined. Okay, so that is silly, and I did that in the wrong order because I thought it was still a multi-definition thing where we do something like prehead equals cur equals list node. So that's why I did that. That's what I was thinking there. Output 4. It's expected 1 1 2 3. All right, so something is definitely messed up here. Okay, and I think this was actually the problem we were having before. After looking at this, we're not actually moving our current pointer. So we need to slide our current pointer ahead so that we can attach more values to the chain. There we have it. All right. Your input 1, 2, 4, output, 1, 1, 2, 3, 4, 4. We're checking the conditions where L1 might be false or L2 might be false, or both, based on using this pre-head pointer and doing this ternary expression here at the end. So this is some nice little fancy clean code that, you should pause it, take a minute to understand it. But otherwise, I think that'll do it for this one. We'll go ahead and submit it. I don't see it hitting any crazy edge cases, so we can see we got the success pointer there. Just took a little longer than we thought it might. We had to debug it. We had to go back and delete some of our code that, we thought wasn't working, which might have worked if we were moving our current pointers. But either way, this is still simpler, easier to read, and that's what you would want to strive for in actual production quality code. Stuff that's easier to understand is easier to work on by multiple developers. And this is definitely easier to understand than what we had before. And I think that will be it for this one. Let's jump into the next problem for the day, the reverse a linked list. Given the head of a singly linked list, reverse the list and return the reverse list. So we are getting the head, what would be the easiest way? Well, I guess we can just reverse it as we go along and do it in a single pass. And then at the end, our end node will actually just be the head node because we will have reversed the links for the self.next. So I think we can just do cur equals head while cur.next. So we want to look at the next node's next pointer and point that to the current node. So I think you would do something silly like, you can't do that though, because then that breaks the chain. So I guess while temp.next exists, okay, so cur.next.next equals cur. Temp equals cur.next. We do that ahead of time. I don't know if that is going to be the same node pointer or if it actually creates a new object. I guess the only thing we can do is go ahead and try it. Cur equals temp. And does this just reverse all of it? And then you return temp? Is that... I don't know if this is true. Or you return cur? Maybe they're the same thing? This might involve some debugging. I don't know if this necessarily works. And it looks like I hit an infinite loop. All right, that's just what you want to see in coding. Current equals head. Temp node equals the next one. So while temp.next, I guess if you have two nodes, this might not even execute. So I don't think you want to do this. I think this would actually work better and still do the same thing. I don't know if this actually changes anything, and it might just be an infinite loop still. Which I think it is. I think we're just bouncing back and forth between the two loops that we just created. All right. Obviously that doesn't work. You could do something more iterative where you just take all of the node values and you put them in a list, and then you iterate through that list backwards and you define a new node. But that uses extra memory, and you need 2 passes. So to be optimal, I think you want to replace them in place. But I don't know if you can do that. So you have 1 as the first pointer. Which points to 2, which points to 3. So you want to take 2, and then you want to point it to 1, but you still want the next value as well. So I think we don't even care about the first node. I think we just do current equals head dot next. Or I think maybe you just want a next node. And next is a Python keyword. And then while there is a next node, all right, this feels like we're doing the right thing now. But if there's not a next node, that's not good. Because we won't be able to return anything. So you almost need a current node too. So we can just do cur equals next node equals head dot next. I think that's okay. Maybe we need both. Maybe we don't need both. But that's the beautiful thing about coding. We just try and keep doing things until stuff works. But either way, we're learning. So we're looking at 2. So what do we want to do with this next node? We actually want to point it to the previous one, but we've lost the previous. So we actually do need the previous. So we have our current and we have our next node. But we are iterating over next nodes, which that seems okay. So I think we still want a temp. Or all right, temp equals our next node. Next node equals next node dot next. Which is a little convoluted, a little hard to understand. So right now our temp is 2. Our next node is 3. So we need to change the temp pointer. Temp.next equals cur. Cur equals temp. All right, so current equals 3. Current equals 2, actually. Man, nodes are fun. And apparently I messed this up somehow. Why? Is it mad at my found cycle? What does that mean? Why are you mad? Current equals the head node. Next node equals the head dot next. This would be so much easier if I just did it linearly instead of trying to do it optimally. Optional list node. I guess if not head, return none. Because you can't get a next node without a node. So you need to check for that. I don't understand what this is mad at though. Is something not spaced correctly? I'm gonna look at this and be like, crap. I guess the other thing you could do to, no, that's a horrible idea. Why is this? The spacing got messed up somehow? Found cycle in list. Where's the cycle? So we're resetting the next node. Current is now 2. 2 doesn't actually point to anything. But I don't think it needs to. Like, we don't care if this 2 is pointing to 1, actually. But we have a concept of 3. So. Alright, I think that we're doing this slightly wrong. Because I'm not actually changing the current pointer. So 1 is always pointing to 2, 2 is always pointing to 1, and then 3 points to 2, and then you have some weird crazy thing. So I think we need to actually start by changing the pointer of the first one with a none. And we can, instead of keeping track of the next, we can look at the previous. So instead, let's do cur equals head. So we still need to keep track of a temp equals the next node, but we'll do this with, we'll just name it a little more clear as this is the temporary next value. And this will be cur next. And then we need to change the current pointer, current.next, to equal the previous. So instead of 1 pointing at 2, 1 is now pointing at none, which is correct. I don't think we need to do anything to previous. But we do need to set our previous node. So now that current.next is equal to previous, the previous can equal the current, and the current can equal the temp next. And this should actually work without the cycle. None is not defined. I swear I've been coding in Python for a while. And then I guess we actually need to return something. We are returning the current. But like I mentioned, we are doing this only for the iteration here. I guess we're actually return the previous, because in this case the previous would be the head node of the list after everything is reversed. All right, accepted. The logic was right. Sometimes the logic is right. Go ahead and submit it. Success. Everything is good. There's some next challenges go along with that. Palindrome linked list sounds fun, but let's not worry about that right away. This is our day 3 items, and I think we boofed some of the acceptance rates on those, but it's okay because day 3 completed. Thanks for joining along with me, guys. Sorry, it was a little bit of a struggle. Swear it'll get better as we go on, and that's why we do this practice. Eventually 2-3 years, if we're still doing videos and not retired by a lake eating Funyuns and Oreos, which we probably won't be, it'll be a lot smoother, and I hope you guys follow along until then and become a small community. You guys can let me know you got your jobs, you can get your promotions, if you had kids, any of that fun stuff. Reach out to me in the comments, and thanks for sticking around. Please leave a like and subscribe if you made it this far. You don't have to like it because I did kind of stumble more than needed. But all right, that'll do it. See you guys. Bye.